9:30.
Don't the girls, like the volleyball girls, have school though?
Have school? Yeah, they've had online school, and they've had to be working on their exams and stuff in their hotel rooms. So.
Hotel rooms.
Oh yeah.
Yeah, they're in.
Yeah, it's kind of like travel ball.
They're playing in Nashville. Oh.
No, they're playing in Murfreesboro.
It's kind of like
How far away is that?
Which is, you go to Nashville, but then you go past Nashville.
How far away is Nashville?
It's about 3 hours.
3. Yeah.
Maybe a little bit more, but 3 hours is what. Alright, so today, y'all have been working the last several days on long division, correct?
Yes.
Okay, and you guys have gotten a lot better at this than we were at the very beginning, okay? Do we still need to practice it? Yes, and we will, okay? In fact, right now, before we step into our brand new stuff, go ahead and get out your whiteboard, which should be in your desk. Okay, it does not go in the backpack anymore. And get out your marker, eraser. Let's see, we already did that. Okay. We're going to keep warming up with just a couple long division problems, but then we're going to step into something a little different. Okay, so right here, breathe. Okay, if you would just do this one right now, right here, 68 divided by 2. Work that out on your board. How many 2's can you get out of 6? What is the most 2's you can get out of 6? Remember, you got to take the most you can. Okay. Just a second. Now, if you've gotten finished, check your work. If you remember how to do that. Over on the side. So, what would you do first if you were doing this problem? Kind of walk us through this and remind us of what to do. Mason, what would you do?
We would do how many 2's can we get out of 6?
Which is how many? Okay. We can get 3 2's out of 6. Can you keep going?
6 minus 6.
Okay, 2 times 3 is 6, so that's what we subtract. And then we bring down the 8.
How many 2's can you get?
Okay. Charlotte, keep going. Tell us what to do.
And then you do.
How many 2's we get out of?
How many 2's you get out of 8, and you should get.
How many 2's can we get out of 8? 2 times.
4.
Okay. 2 times 4 is 8. That's That's how we got that 8 right there, because 2 times 4 is 8. When we subtract that, we get 0. Do we have a remainder?
No.
No remainder.
34.
34 is our answer. And if you multiplied
34 times 2.
2 times 34, you should get this right here. 2 times 4 is 8. 2 times 3 is 6. There you go. Okay. All right, let's clear that off and let's do this second one. 96 divided by 3. 96 divided by 3. Go ahead and work that one out. Let's see how good y'all have gotten already at this. Ready for it? Okay, check your work. And some of these are a little on the simpler side, but check your work. Okay, Ray can help us out here.
So you can see how many times did you put 3 on 9? I put 3 at the top.
Okay,
And then multiply. I got 9.
3 times 3 is 9.
Got 0. Run down to 6.
Okay.
Put 2 up there.
Because 2 groups of 3 come out of 6. 3 times 2.
And 6 and 6.
Wiggly lines there. Okay. All right. Whoa. It just ate my 0. Did y'all see that?
Yeah.
All right. So 32 we're thinking is our answer. And if you're not sure, what's nice is you can check, and that makes you a whole lot more confident that, hey, I did that right. 32 times 3.
That's 6 and that's 1.
Okay, there's the 96, and there's the 96. That looks like macaroni and cheese, that color, doesn't it?
Yeah.
Random Thoughts by Miss Wendy. Okay. Anyway. All right, so just a little bit, and like for the next several weeks, I will probably put at times maybe one division problem, one multiplication problem up there just to practice, because we don't want to lose that at all, because you're going to continue to build on our multi-digit multiplication and division. You're going to continue to build on that even through 5th and 6th grade. And so if you're really good at it when you get, with what we do, when you get to 5th grade, the things you do there will be a whole lot simpler for you. Okay, and we want that to happen. We want it to be an easy transition when you go. All right, so now we're ready to step into something a little different. So if you would put the top on your marker and just stack up your eraser, your board, your marker, and just really let it rest. We're not going to be there for a little bit. You're going to feel like we took a little vacation, a little detour from division, multiplication, okay? We're going to be thinking about something for a few days that really will help us with division and multiplication and all these big things, okay? So it's funny to me that our book has us go along, and then we stop and talk about these few things, and then we start back up with multiplication in another few days. But that's the way they chose to do it, so we're going to try, do it this way and be good with it. Okay. You see this word right here. Okay, and this word was also in our learning target when we started, and it's here. I can find factor pairs for numbers to 100 and use understandings of factors to define prime and composite. So we have 3 new words today. Our first one is factors. We'll get to this one that starts with P, this one that starts with a C later. When those start popping up, we'll come write those on the board. But we've got really 4 in the next few days, 4 main words that we're going to work with. 3 of them we'll talk about today. Let's look at this right here, this group of dots. This is actually an array instead of just a line of dots. What would the multiplication problem be for this array right here? Think about it. This can be a multiplication problem. What would it be? You gotta count them up. Yeah.
1 times 8.
Yeah, 1 times 8. There's only 1 row, and it is 8 dots long. So 1 times 8. Okay. What about this array? What would the multiplication problem be for that array? Ishmael? 2 times 4. Okay. Okay. Both of these problems equal what?
The same.
They do. What number do they equal?
8.
8. Both of these equal 8. Okay. Notice that? So they both have the same answer. All of these numbers that we're multiplying are factors of 8. Okay? A factor, y'all hear this because this is important. A factor is just a number that's multiplied by another number to equal a product. Okay? So if I said, oh, what are the factors of 8? Okay, well, we've got a 1. We've got a what?
2.
Oh,
8.
an 8. We do have a 2 right there. And we have a
4.
4. Is there any other numbers that when you multiply them together make 8? Let's think for just a minute. Can you think of anything else that when you multiply it, it equals 8 besides 1 and 8 and 2 and 4? Now, I know we could switch the order of the, we could say 8 and 1, but it's still the same numbers. Any other numbers? 3? Can 3 make 8? No, 3 times 3 is 9. That's close, but it's not, we're not going to get 8 there. What about 5? Would 5 make 8?
No.
No. Okay. We've actually found all of our factors of 8. Okay? And so 1, 2, 4, and 8. Those are the factors of 8. And so what we're going to be working on today is finding the factors that make a number when you multiply them together. That's all factors are. Okay? Maybe that would be helpful to put that beside it. And let me look at how I don't want to say it too differently from what's on here. Okay. My magnets have all. We used to have them all over the place. Yeah. Because that's what we're looking at today. Alright, so numbers that are multiplied together to get a product. Numbers multiplied together to get or make a product. And a product is just the answer to a multiplication problem, isn't it? Okay. So factors are just those little guys that are multiplied together to make a number. Okay. So let's keep going with this idea. What is the multiplication sentence that could come out of that array that's on top? And count them carefully. There's a bunch of them. Just to help us out here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. Sometimes when we're far away from it, it's hard to hold our place there. All right. So what would it be?
It would be 2.
This one.
It would be
How many are there? How many did we just count?
18.
So 18 times what?
1.
18 times 1. Could he have said 1 times 18?
Yes.
Yes. What about this one right here? Okay, yeah. 9 times 2. Both of them equal what?
18.
18. Okay, 18. All right, so think for a minute. Just like with our other number, can you think of anything else that when you multiply it together makes 18? Yeah.
6 times
6 times 3. We could make an array. Like that, couldn't we? Okay. 6 times 3 equals 18. Can you think of any other way to make 18? This is where our multiplication facts come in very handy.
8 times 8 plus 8. 10 plus 8.
Not adding, we're multiplying. Remember, factors have to do with multiplying.
Yeah.
Yeah, we could add it a lot of ways, couldn't we? Okay, so look at all the factors we've collected so far. Now, if we wrote them in order, like, from smallest to largest, we've got 1, and this is how a lot of people, I'm fixing to show you a little video clip, and then we're going to do some of this. A lot of people will write it like this. We've got 1 and 18. They'll spread them out far, okay, and connect them with a little arc right there. All right, then we said 2 times 9, 2 and 9, and I'm just separating them with commas. You know how you list things? Have y'all done that with Miss Elizabeth yet, where you separate things with commas in a list? Like if I said, I'm going to the grocery store and I'm going to buy milk, comma, Diet Coke, comma,
We did that.
candy bars, comma. Okay, so you know what I'm talking about. Okay, and then we also said 3 and 6, so that would come next. And the 6, whoop, let's put a comma between them. Now, is there any numbers, we've counted to 3. What about 4? Can 4 multiply by something and make 18?
Yeah.
No, it makes 16. 4 times 4 is 16. 4 times 5 is 20, so those don't work. What about 5? 5 times...
No. It'll be 15.
Nope. And then we get to 6. So we've talked about the numbers in the middle. So there are no other factors for 18. So we would draw an arc between each of those that go together. Sometimes it kind of looks, mine's a little messy right here because I've had those dots in the way, but sometimes it almost looks like a little rainbow, over your numbers. Okay. All right, so in a second, we're going to watch a lady. It's a very short, probably 3 minutes or so, little video. Now, she is from another country. You can tell because she talks with an accent. So really tune in so that you can try your best to understand her. Okay. And she just talks about finding the factors for numbers. And it's quick. I thought it would be good to watch, though, because she does this very thing right here. There's also another way that we're going to show how you can, it's called a factor tree. It's another way of writing your factors. We'll show that after the little video. Okie doke. Let me switch to that. Okay, put your markers down, please. Oop, I don't need that. I need that.
The writing is
Okay. Wait, stop. Let's go here and erase that and here. There we go.
Can you turn the lights off?
No, we're good. This is, yeah, just a little over 3 minutes.
Factors for the first time. In this short tutorial, you will find out what factors are and how to find factors using multiplication. Factors are whole numbers that you multiply together to get another number. So in this example, 2 times 5 is 10. The factors are 2 and 5. You will often be given a number and told to list all its factors. Well, you could just think of any numbers that multiply together to give 12 in this example, but a better plan is to use the same simple way every time. Take a look. The first thing you do is find the simplest way of multiplying to 12, and you start with 1. So 1 and the number itself are always the first factors you list. Write the factors down in pairs, 1 here and 12 over here. We will fill in the space between with other factors as we go along. For each factor pair, use an arc to show which factors multiply together. It helps keep your thinking clear and stops you from accidentally forgetting to write a factor down. Okay, now you try 2 times a number to make 12. Well, 2 times 6 is 12. List the 2 and the 6 and put the arc in. Then 3 times a number. 3 times 4 is 12. List the 3 and the 4, put the arc in. 3 and 4 are consecutive numbers, so we know we finished because there's no whole number between those two. We've just found all the factors of 12. Notice that because we worked from the outside in, the factors are in order. This is the clearest way of showing all the factors of a number, and using the arc for each factor pair shows your thinking. We'll do one more example. We'll find the factors of 16. Start with 1 and the number itself. 1 and 16, use the arc. Now go to 2. 2 times the number. Well, 2 times 8 is 16. What about 3 times the number? Is 3 a factor? Well, 3 times 5 is 15. We can't get to 16. 3 is not a factor of 16. Now 4 times the number. 4 times 4 is 16. When a number is multiplied by itself, like the 4 times 4, we just put it in the factor listing once, without any arc. And there are no more factors. We found them all. When you're listing all the factors of a number, remember, always start with 1 and the number itself, with a good space between. Then using multiplication, try 2 times, 3 times, 4 times, 5 times the number and up. And when your numbers meet in the middle, you have finished. Always use the arc to show your thinking. And now it's your turn to practice. Have fun with this and become fantastic at factors.
Okay.
Created using Powtoon.
Catches you off guard just a little bit. Alright, so just a quick little video to just hear it one more. What did I just do? Okay. Gotta get rid of this. Alright, so she used the number 16, and they're using the number 16 as well. One of the reasons 16 gets used as a good example is because it has that 4, and it's 4 times 4. And when you're listing the factors, you don't have to write 4 twice. Okay, you can just put it once. If you forget and you put it twice because you know it's 4 times 4, it's okay. You just don't have to. Okay. So what are the factors of 16? Well, let's think about what she just told us. So take your board, and we're going to make that, even though we've just seen it, we're going to make that list of factors with the arcs on our board. Okay? Alright, so she said always start off with what number?
1.
1. It's the easiest thing to do. Always start off with 1. Let's get a color we can see good. And the numbers. So 1 and 16, and we're going to put them with some space between them. So write those on your board. You might want to turn your board back the long way. No. Oh. Alright, and you're going to draw that arc between them because those go together. Now, she listed hers without commas in between. I'm going to say let's put the commas there because how often do we accidentally write our numbers close together and a 1 might start looking like an 11 if it's beside something else, or a 12 or a 13. So let's put our commas in between just to help us separate our numbers. Okay? All right, now they've given us some help right here. 2 times what is 16?
8.
2 times 8. So we're going to put that 2 right here. We're kind of going in order like she suggested. 1 times something, 2 times something. And if we find one that doesn't work, we jump over and go to the next number. Is there 3 times something that makes 16?
No.
No. Okay. The closest we can get with 3 is 15. 3 times 5. Doesn't work. So we don't worry about 3. What about 4? 4 times 4. So how many times do we need to write that 4?
1.
Just once. Just once. Now 4 and 4, there's no numbers in between there, of course. And we've already talked about 3. And that was 3 times 5. So 5 doesn't work. We've got a... What about 6? Can you do 6 times something to make 16?
No.
6 times 3 is 18. It's close, but it's not there. What about 7?
No.
No. 7 times 2 is what?
14.
14. That's about as close as we can get. Okay. And then we get on into 8, which we already have, and then we're at our last number. So we have found all the factors. I didn't make my arcs, did I? Okay. All the factors of 16. So as you might can guess, our day today is going to be just filled with, here's a number, let's find the factors for that number. Now I want to tell you a couple things about factors. That might help. Let's switch over to another screen before we get there. Okay, the word factors starts with which letter?
F.
Okay. I want you to also know, whoop, I spelled it wrong. This word. Okay. Finite. Finite is how you pronounce that. Okay. You ever heard that word? No? Have you ever heard the word infinite?
Yes.
And it looks like this? What does that mean? Or when you've heard infinite or infinity, what do you think they're talking about? Yeah, what do you think?
It never stops.
It never stops. That's a good way to say it. Anybody want to say it a little differently? Or what you heard? What have you heard?
Like on Toy Story, Buzz says infinity and beyond.
To infinity and beyond. Yeah, that's probably the most common place we've heard that word. Now, that's this word, okay, with this prefix, which means the opposite of the word I want you to know.
Infinity.
So if something is infinite and it never stops, it could keep going, then finite means the opposite, that it stops, that it only has a certain amount. Okay, so this is the thing about factors. There is only a certain number of factors for a number. It does not go on forever. Okay, Miss Wendy, what's the big deal? Because one of our other words that we're going to learn does go on forever. We want to know the difference. We'll talk about that word a little bit more in another day or so. So factors are finite. There's only a certain, think about 16. We had 1, we had 2, we had 4, 8, and 16. That was it. That's all the factors. Nobody's going to invent anymore. Nobody's going to create anymore. That's all the whole number factors. Okay? So factors are finite. And there are far fewer. Let's get rid of our infinite word here. Far fewer factors. What is she talking about? There's this other word we're going to be learning about in another day or so, and it's called multiples. You hear factors and multiples, you hear those two words together a lot. Multiples go on forever. There are many more multiples, but there are far fewer factors. Y'all talked about alliteration yet with Miss Elizabeth?
What is that?
No.
We're just not, we gotta sync up math and reading. That alliteration is where you've got the same letter sound a bunch of times. Kind of like Peter Piper picked a peck of pickled pepper. You know, you hear the P sound over and over and over. Okay. So far fewer, hey, when y'all get to that in reading, you go, hey, we got a math example we can use. Far fewer factors. Okay? Far fewer factors. And really, that's going to help you more when we start learning multiples. People get multiples and factors mixed up all the time, and that's why I'm telling you some of these things. And we'll talk about these for lots of days, okay? Till we get it in our noggins. Okay, now, some other things about factors. This one doesn't work, Miss Wendy. This one works. Okay, so factors. All right, here is just some information, some helpful information. Okay, I think this is the time. What did we just? Well, just watch. We just worked with the number 16, didn't we? Y'all put your markers down, okay? If I take the factors of 16, they're going to be able to divide into each other, aren't they? Do y'all see that? Okay. Okay. So factors can also divide into the number that they're a factor for. Now, what some people don't realize is that there are some helpful things to know. Okay, I want this to help you. When did you talk about odd and even numbers? Was that last year?
Yes.
Or before last year? Okay, so y'all know odd and even pretty good? If I picked any number, could you tell me if it was odd or even? Like if I said 15, is that odd or even?
Odd.
It's odd. If I said 8.
Even.
Even. Okay, I want you to know something.
2, 4, 6.
Any even number is divisible by 2. 2 will always be a factor of any even number. Okay? So 2 is a factor for any even number. Because, you know, sometimes we're asked to find all the factors, like that lady said in the video, but we get stuck and we forget one sometimes. So I'm trying to tell you there's a few little helpful hints that will help you know maybe if you've missed one. Okay? 3 is interesting. Okay? This is a really interesting one because sometimes we'll have a very large number we've got to find factors for. Okay? If you can take the digits of a number, let me think of one. Okay, let's say I had this number, and if I wanted to divide it by 3, I wanted to know if 3 would go in evenly to that, and there not be a remainder. Okay, put your marker down. If the digits right here can add up to a number that has 3 for a factor, it's divisible by 3. Now that's a hard one to remember. What is 9 plus 2 plus 1?
9 what?
12. Okay. Is 3 a factor of 12? It is.
Yes.
Because 3 times 4 is 12. So when I divide this number, there's not going to be a remainder. Because 3 is a factor of this number. Let's prove it. Let's prove it. 3 goes into 9 3 times. That makes a 9. So we subtract it. Bring down the 2. Can a 3 go into 2?
No.
Can I get a group of 3 out of 2?
No.
No, so I'm going to have to put a 0 right there. We haven't really done that yet, but we will. Okay? 3 times 0 is what?
0.
0. That's what I subtract, just like always. I'm ready to bring that down. How many 3's go into 21? 7. Okay, 3 times 7 is 21. No remainder. Okay, so 3 times 307 make 921. If you can add up the digits and they are a number that has 3 for a factor, then 3 is also a factor of that number. And that's a big mouthful. That will be helpful down the road. Okay? Have a seat. All right, something else that's helpful, and this one's easy to remember. 5. Any number that ends in a 5 or a 0 has 5 for a factor. Okay? Numbers that end. So is 45, does 45 have 5 for a factor?
Yes.
Does 2000 have 5 for a factor?
Yes.
Any number that ends in 0 or 5 has 5 for a factor. Just think about it. When I count by 5s, I'm going to hit every single number that has a 0 or a 5 on the end. Okay? Those are our main helpful ones. This one is, I know it's a little confusing, and that's why I didn't write it, because it just takes a little more explanation. Okay, let's jump back into what we were doing. All right, so what I want you to try to do is to write the factor pairs for 14. Sometimes you'll hear people say it that way. You might hear somebody say write the factors, and you might hear somebody say write the factor pairs. Well, how much is a pair?
10.
I have a pair of shoes on. How many shoes do I have on? 2. A pair of pants. It's not really 2 sets of pants, but it has 2 legs, doesn't it? A pair is 2. Okay, factors come in pairs because it's this times this. This times this. They go together. Okay, so what are the factor pairs for 14? Let's do this one together. Help me out. Get ready. Get your marker. Okay, we're going to start with 1 and 14. We're going to draw that arc. Okay. Then she said go to 2. So we know our multiplication facts really well at this point, or should. 2 times 7, yes. Okay. Okay. 3 times something. Can you get to 14 by multiplying 3?
No.
Now what's the closest we can get? 3 times
12.
3 times 4 is 12. Okay, so 3 doesn't work. 3 doesn't work. What about 4?
No.
It doesn't work. What about 5? Does that end? Look, I don't have to go 5. 5 times what? Does that end in a 5 or a 0? No. 5's out. Boom. That quick. Okay. And if I had forgotten the 2, I need to go back and remember it because that's an even number. Okay. My hair is caught on something. Okay. What about 6?
Yes.
6 times what is 14?
No.
It's almost like prove it. 6 times what? And it's not, is it? It's not. 6 times 2 is 12. 6 times 3 is 18. No 14 in there. Okay. Now, the next number I'm going to count is 7. It's already there. So we are done. We are done. Those are all of our factors. Now, I've got that big space there. That's okay. But 1, 2, 7, 14. Those are the factors. So if somebody said list them, I would go like this. Okay. All right, let's try one other number. Let's try the number 18. No, we've already done that one, haven't we? Let's try this one, 24. Okay. All right, what's the first factor pair we're going to always list? Yeah.
2.
Okay, say it really loud. Okay, 3 times 8. Hold on to that one. We're going to come back to that. What's the first one we're going to list? 1 times what? 1 times what?
24.
1 times what?
24.
No, we're not awake. Not everybody's with us. Okay? Okay, 1 times 24. There we go. Draw the arc. Is that an even number?
Yes.
Is 24 even? Yes, so 2 is definitely a factor. I just got to figure out what it goes with. 2 times what is 24? And if you don't know, how can we figure out? Okay, watch this. You're right, but I want you to watch this. Let's say I know that number's even. I cannot remember what to multiply it by. Watch. Do this. And that will give you the other number that you multiply by to get 24. Which is what? Y'all said it a minute ago. 12. Okay. All right, 24. All right. Kennedy mentioned 3 times 8. Oh, I may not have enough room this time. I have to squish them. Bless you. Does 4 work? Is 4 times something 24?
Yes.
4 times 6. Okay. Look at all the numbers we have. We've gotten all the way to 4 and 6. I'm sorry, why do I always forget those? 3 times 8, 4 times 6.
Oh, I am too. I am too.
Yeah, don't forget to put the arc because that puts them together. Now, 4 and 6 was our last one. And what's the only number in between 4 and 6? 5. Is 5 going to be a factor?
No.
No. It ends with a 4, not a 5 or a 0. I don't have to sit there forever and go, okay, 5 times this, 5 times... No. It does not end with a 5 or 0. 5 is out. Are we done?
Yes.
We are done because our two sides have met in the middle. And we know the one number that's missing, a 5, it does not belong. So that is all the factors. So I would write them like 1, 2, 3, 4, 6, 8, 12, and 24. Wow, 24 has a bunch. Okay. Alright, sometimes you're asked to write the multiplication sentences. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Sometimes you're just asked to write the factors. Okay? Alright, let's try one more. Y'all are getting better at this. Alright, I'm going to let you try this one on your own. I just want you to write all the factors of 7. Okay, let me give you a second to do that. Take you a minute. Miss Terry knows that. Alright, keep going. Get them all listed. Start with 1 like we always do. Okay. Draw the arc. Give you another few seconds. Sometimes they take a while.
No, there's only two.
You said the number 2? There's 2 of them?
No,
Is that what I
there's
heard?
only one.
Well, you have factors come in pairs, so you have to have at least 2 because they multiply by each other. Okay, so what do we have? Let's start it off. Okay, always start with 1 in the number, so we know we have 1 and 7. Okay, draw that arc. All right, so what would come next? 2 times.
Nothing.
You can't get there. It's an odd number. 2's not going to work. It's an odd number. I can get rid of 2 immediately.
Oh, I thought it was 35 divided
Do what?
by 5. 35 divided by 5.
No, but you. This is multiplying, not division.
Where'd you get 35?
He's doing division to get to 7. It has to be multiplication. Okay, 3 times something?
No.
4 times something?
No.
5? No, for sure. It's not. Okay. 6?
No.
Okay, and then we're at the number. Okay, so how many factors does this number have?
1.
No,
2.
2. 1 and itself, right? Okay, this is an important moment. I did this on purpose because this is a special type of number called a prime number. And this is one of our other very important words. A prime number only has 2 factors, 1 and itself. It has no other factors. And there's a good large, I'd say 1 handful, but there's about a good large 2 handfuls of numbers when you count from 1 to 100 that are prime numbers. Okay? And we'll talk more about prime numbers as the days go on as we're doing factors and multiples. But I want you to know prime numbers have only 2 factors, 1 and themselves. Okay? Now, what's the opposite of that? I wish I could go back to the screen we were on a minute ago with 24. 24 had, let's see if we can just list them. It had 1 and 24. It had 2 and 12. It had 3 and 8. It had 4 and 6. That was it, right?
Yeah.
Okay. 24 has many factors, right? More than 2. Okay, so here's the other special word that we're looking at. If a number is not prime, then it is composite. Okay? If a number is not prime, then it is composite. A composite number has more than 2 factors. Okay? Prime number, only 2 factors. And that would have to be 1 and itself. 1 and itself. That's a 1. Composite numbers has more than 2 factors. Later today on our problem set, it's going to have you find the factors for some numbers, and then it's going to ask you on the very end of the question, is this a prime number or is this a composite number? Well, I'm going to leave this up here. We've got to just get used to these new words. If it's prime, it only has 2 factors. If it's composite, it has more than 2 factors. Those are not hard things, but you know what we do all the time? We get those 2 words mixed up. This is how I told our 4th graders to remember it. You see how the word prime is shorter than the word composite? Okay, y'all give me your eyes for a second. Prime is shorter, so think of only 2 factors, the shorter word. More than 2 factors, the longer word. Maybe that helps some of you. That kind of thing helps me. Okay? We'll get used to it the more we use it, but that's what those 2 words mean. Okay? All right. So let's just grab a number. Let's look at the number 35. Okay? So clear your board if it's not clear already. Put 35 up there, and we're going to find 35's factors. Then we're going to decide, hey, is this composite or is this prime? Okay, we're going to start with what? 1. Now, you know what? Let me show you this other way as we do this one. Some people like to make a T-chart like this. This is the same as the rainbow thing. It's just a different way to write them. And they would say 1 and 35. I like the rainbow way because you can see it better, I feel like, than this. But I'm just showing you this because you might see this somewhere. Okay? Will 2 be a factor of that number?
No.
You should know immediately because this number is what? Odd. No, 2 is not a factor. What about 3?
No.
3 times what is 35?
7.
3 times 7 is 21.
5 times 7.
Oh.
5 times 7 is 35.
Don't put that
We
on.
just weren't there yet. We were at 3.
Oh.
Okay, does 4 work?
No. That's 28.
4 times what is really close to this number? It's a little bit bigger. No. What's 4 times 9?
4 times 36.
36. So that's as close to 35 as you're going to get, and it's bigger. Okay. So what did you just say a second ago?
5 times 7 is 35.
5. 5 is the next one. 5 times 7. You know your multiplication facts. You know that's a fact family. The only number left between 5 and 7 is 6. Can I multiply 6 times something to get 35?
No.
No. 6 times,
2. 6 times 7.
what's as close as we can get? 6 times
5.
5 is 30. 6 times 6.
6 is 36.
6 times 6 is what?
36.
Okay. Now,
37.
what do I do with the T-chart if it's a double number? Go ahead and write it so we know what you're multiplying by. Okay. But if you wrote a T-chart like this, and then somebody said, okay, but list the factors like in a row, like we wouldn't write the 6 twice. We would just say 1, 5, 6, 7, and 35. Okay, here's the big question. Is 35 prime or composite? Look at the words up. Look at the words up there. Let's raise our hand. To help you remember. What would it be? Composite. Composite. It has more than 2 factors. Okay. All right, we are about to go to our problem set. I want you to look up here. So put the top on your marker and lay it down. We'll take our break in just a second, but I want you to see this for just a second. So you have a chart like this today. I need your eyes. Please lay the erasers down, the markers down. You have a chart. It says multiplication sentences. And then all it does is give you a number. All right, so you're going to write every single multiplication sentence you can think of that makes that number. All right, they started with 4, and they wrote 1 times 4, 2 times 2, and that's it, isn't it? Then they listed the factors with commas, like we've been doing, and then they wrote a C. You get to write P or C. You don't even have to write the whole word prime or composite. You can write just a P or a C. Is it prime or is it composite? Okay. All right, I think we'll know what to do there. Let's see. That's going to go on for a little while. Okay. This, you just write the factor pairs. This is like a T-chart. Factor pairs for 25. Well, you got 1. You got 1 and 25. What else makes 25? Yeah. 5 times 5. What else makes 25?
That's all.
Okay. So you might not fill up the whole box. You see what I'm saying? They just gave every box the same number of spaces. You may not fill up every space. Factor pairs of 28. Factor pairs for 29. Okay? All right. Let's put our boards in our desks. Put our marker bags and erasers in our desks, not our backpack. Lay your workbook out, but we're going to go ahead and take our quick break before we start on that.